I'd like to continue our discussion. I know you're concerned about the record slow rate of refreezing of the Arctic ice. Can you speak to that point more for us?
Yes, well, this year, the ice has scarcely advanced. This is usually the autumn advance of the ice is in full swing, but it hasn't advanced. And in fact, the area of ice now, today, is the lowest it's ever been for this day of the year. So although the ice didn't reach a record low area in mid-September, which is the peak of melt, because it hasn't been growing since, it's now on a record low. So this has implications because, firstly, such a slow regrowth can only be caused by two things. One is the fact that the air temperature is much warmer, and the other is there's a lot more heat in the water column, and that heat is partly from melting of the ice in summer, leaving open water which warms up, and partly it seems to be from a warmer air mass coming in from the Bering Strait into the Arctic Ocean, which is also very, very worrying, because a water mass that's actually a warmer current is something that's going to give you warming of the seabed all the year round, really greatly increasing the rate of melt of the layer that protects us from methane emissions.
And to get the geography straight for myself and viewers, the Bering Strait lies between Greenland and Canada, correct?
Between Alaska and Siberia.
Ah, okay, I've got it wrong. I see. Okay, that's where the warm water from the Pacific is moving upward.
Yes, no, normally warm water from the Pacific comes in to Bering Strait and turns right. That is, it goes across the north of Alaska, and that helps to melt ice north of Alaska, and has in fact melted away all the methane, so that the scientists who've been worried about this seabed methane have thought, for instance, scientists at Scripps Institute of Oceanography have thought, well, let's go and look at the same thing, that shallow water with sediments north of Alaska, and see if we can study the methane emissions from there, so we don't have to go into Russian waters. But when they got there, they found there wasn't any methane. That quite a long time ago, because the water is warmer in the summer from this warm current, all of the methane evaporated, all of the methane was emitted, and the sediments don't contain any anymore. So the water temperature has a big effect on the stability of methane in sediments. So the Alaskan methane has gone.
And that happened on our watch, invisible to us. We paid no attention.
Well, we don't know how long ago it happened. It could have been hundreds of years ago. It depends how long that current's been flowing. But we're now seeing it, of course, happening very actively in the Siberian Arctic.
Since we're talking about methane, I wanted to ask you a personal question. If you've been in touch with Natalia Shakova, Dr. Shakova, or her husband, Dr. Semiletov, have you spoken to either of them recently?
Yeah, well, they're working up their results at the moment, because they had a very successful voyage last summer, which is a year ago now, in a Russian ship. And so they've been working up their results, and I haven't been in contact with them recently, but I have been in contact with another scientist from the same laboratory who's been working on the emissions of methane from the Sea of Okhotsk. And he's been doing this for some years, but he's been writing his papers in Russian, so the world wasn't really aware of what he was doing. But they're finding large emissions coming out of plumes of methane coming out from the seabed of the Sea of Okhotsk. That's west of Sakhalin, south of Siberia. And this is an interesting area because it's actually been studied by Western scientists, because a few years back there was an oil discovery on Sakhalin Island, and the Russians invited the West in to work on it.
Ouch, when you say oil discovered. Again, the information from my source in the US intelligence community is that basically the military and the intelligence community, except for some good actors, is welcoming the oncoming Blue Ocean event because there's more mineral and drilling opportunities. And that's very sad for humanity. Good for...
Secretary of State Mike Pompeo actually believes that melting ice caused by climate change is a wonderful thing because it opens up new business opportunities. This is what he said during his appearance at the Arctic Council in Finland.
The Arctic is at the forefront of opportunity and abundance. It houses 13% of the world's undiscovered oil, 30% of its undiscovered gas, and an abundance of uranium, rare earth minerals, gold, diamonds, and millions of square miles of untapped resources. Fisheries galore. And its centerpiece, the Arctic Ocean, is rapidly taking on new strategic significance.
Good for short-term profits.
Yes, I mean, that's the motive behind Mike Pompeo's sort of bizarre speech to the Arctic Council last year, in which he said it was, while he welcomed the emergence of trade across the Arctic from the Northern Sea route, he hated the fact that there was cargoes carried by Russian ships, Chinese cargoes carried through the Northern Sea route by Russian ships. And this was a terrible threat. In fact, it's no threat at all. It's just, but he thought America must respond to this threat by building lots more warships and patrolling the Arctic and that kind of thing, just raising the temperature unnecessarily.
Again, it just totally disgusts me how the current political regime in the United States is willing to throw all future children under the bus for the sake of short-term profits and their economic warfare. It's like, don't you have any humanitarian instincts left in you? Don't you have any ethics at all, ethical compass? And I just think these people don't. Their compass has been shattered a long time ago by money.
Well, of course, thinking of ethics, the US president has just said that all the 500 or so children that were dragged from their mother's arms and stuck in Gestapo camps are being very well looked after. They got really nice soft cement floors to sleep on and so on.
Yeah, and we give them Sesame Street to watch every day and Snickers bars and anyhow.
Anyway, that's this absence of humanity. But the course, the amazing thing is that the Arctic Council, which is a council of basically scientists from each of the countries that have Arctic territory, so America is one of the 8 countries, but they really just work together to improve the state of the Arctic, to do develop search and rescue for ships that might be in trouble, do positive things for the inhabitants of the Arctic. And they were amazed and appalled when Pompeo went and kind of stomped around like an elephant, saying all these things about the need to fight against the enemies who are trying to do things, when in fact there's no enemies. There's fact the Arctic is a wonderful place because you don't need to have any of this kind of warfare stuff unless you deliberately foment it, which is what...
Well, war is good for business. Let's remember, war is good for business. So where do you see the Arctic ice pack headed in terms of what's termed a Blue Ocean event, or BOE?
Well, it will be soon. I mean, I've been attacked viciously for actually predicting which year that will happen. So I'm not predicting anything anymore.
Yeah.
But all I can say is it's going to be soon as opposed to late. But most of the modelling groups, for instance, the British Met Office, talk about the ice in the summer not disappearing until the end of the century. That's the and that's obviously rubbish. But
I should put some faith in the Met. Now
no, yes, no, their modelers are hopeless, and so it's certainly going to be within the next few years, or very few years.
Well, I can quote the member of the U.S. intelligence community who I am in touch with as having informed me that the Summit supercomputer in America is predicting BOE, Blue Ocean event, in 2023 and or before. And to remind the audience or to inform the audience, Blue Ocean event doesn't mean zero ice. It just means less than a certain amount of ice. What's that threshold number?
1 million square kilometers is
okay, as opposed to what's the square kilometer measure of the entire Arctic Ocean?
Well, in winter, it goes up to about 18 million, and in summer now it goes down to 4 million.
So it's varied between 4 and 80 million, but
yeah.
When it's less than 1 million, it's called a Blue Ocean event.
Blue Ocean event, yeah. But I mean, I'm not happy with that name. I mean, it's in a way that event has already happened, because the physical effects of the loss of ice don't depend on the ice disappearing completely, because the big bad effect, which is the release of methane from the seabed, happens already because the shallow water parts of the Arctic are already ice-free for several months of the year, enough to warm up the seabed and cause the permafrost to melt and the methane to be released. So as far as the methane threat is concerned, the threat's already there in full, and we're not going to get a bigger threat by removing the ice from the North Pole, because it's only the ice around the edges of the Arctic that affects the methane release.
So, but a Blue Ocean event, which I will agree with you and say that's, if not happened, it's been in process, because it's not going to be a sudden event. Mm-hmm. It's been in process for a while, and the danger, correct me if I'm wrong, is that the reflectance, the albedo of the Arctic changes from a net reflector of incoming solar heating energy to a net absorber of incoming solar heating energy as there's less and less ice. And so the BOE kind of marks a point of no return.
Well, in fact, there's a paper coming out in Nature this week, which is a kind of in a battle, because we've got a paper that's been accepted, which covers almost the same ground. So we're really annoyed, but it deals with this question of albedo and the fact that if you take away the ice, you reduce the albedo of the whole planet, in fact. So you're reducing the amount of you're increasing the amount of heat retained by the Earth, and therefore you're accelerating warming. Now, the blue ocean event is associated with the sea ice in the Arctic Ocean disappearing, and our paper, which we maintain is better, deals not only with the sea ice retreating, but with the snow cover on land retreating, which is retreating at about the same rate. You've got a lot of Arctic territory, which used to be snow covered in winter, is now actually not snow covered. Places you don't expect to see bare land in winter, like in Alaska and Siberia, are actually have lost their snow. And that also causes a reduction in albedo.
Yeah,
that's a big thing. The other thing, about, I guess, about so that's the main thing about a total blue water event, is the further reduction of area of ice cover.
So when would your paper be published in due course?
Well, we hope in the next within the next month. It's in a different journal, so there's a battle going on.
What journal will it be published in?
This is a remote sensing journal. The edit. I'm one of the authors, but the other author is my graduate student. So I was encouraging him to write that, and he's co-author on that. It's a big thing because, in one sense, the blue water event has happened. As far as methane is concerned, we're dealing with blue water. But the other thing about it is, once the ice cover goes, it's not going to come back. I mean, you're not going to get a big ice cover in the Arctic Ocean anymore once it goes for the first time, because when it's gone completely in the summer, the water warms up much more than if there's an ice cover there, because the ice cover keeps the temperature down to 0. But when there's no ice cover there, it warms up, and we found temperatures up to 11 degrees in the summer in the Arctic Ocean, where normally it used to be frozen. And that extra warming puts so much heat into the water, as it did in this last experiment we did on the Sikuliaq. It puts so much heat into the water that you have to take that heat out before you can start freezing. So it takes a long time to take the heat out. So that's what's been happening this year. The slowness of the ice to advance is because you've got to take more heat out of the ocean before you can cool the water down to the point where ice cover forms. And each year that you have open water, there's more heat in the water column. It takes more time to get rid of that so that you can start growing ice.
And you said earlier in your explanation that once it's gone, it won't come back. And yes, I was going to add then, but I'll add it now. It won't come back in any time frame meaningful to human existence.
Yes, that's right. It will. The length of ice-free period will go up and up, and eventually, not many years, or well, maybe 2 or 3 decades ahead, you won't get any ice at any time of year, even winter. But initially, the ice will completely disappear in the summer, and then the period of disappearance will gradually extend until it's gone all year.
Yeah. Well, I don't know if that's any cheerier a note.
Well, it depends. I think if you wanted to swim in the Arctic Ocean, you'll be able to.
Can we think of anything, any up note, any note of hope or action? Well,
I think, my hope is that, in fact, my only hope, which I always stress because I put it in my book, A Farewell to Ice, is that if we can take carbon dioxide out of the atmosphere, we've saved ourselves.
When fossil fuels are burned, molecules of CO2 are produced along with other gases. In a carbon capture system, before going up the smokestack, this mixture of gases is sprayed with a chemical that attaches only to the CO2. The chemical is then heated to release the gas, producing a stream of pure carbon dioxide that's compressed and sent through a pipeline to a well. The chemical is recycled and used again and again. At the well, the CO2 is injected deep underground, where it spreads out into porous layers of rock and sand. Impermeable rock layers above act as a cap, preventing the gas from rising up and eventually out into the atmosphere. In theory, at least, the gas should stay buried forever. But CCS is expensive, and because it requires so much heat and power, it cuts the electrical output of a generating plant by as much as 20%. As a result, the technology has been slow to be adopted. The pace will have to pick up, scientists say.
And it's the only thing we can do to save ourselves, because if all of the reduction of emissions, first of all, it's fake, because nobody's going to really reduce emissions to the extent they say they're going to. But even if you reduce emissions down to zero or close to zero, you've still got carbon dioxide increasing in the atmosphere. And since carbon dioxide stays around forever, you're not...
Not forever. I think half-life is 300 years or something like that. Or
oh, well, it's the estimates now are more like 10,000 years.
oh, yeah. Oh,
you take account of all the various biological processes. It's frightening. And so it's a permanent thing. You release CO2 into the atmosphere, it's there, unless you physically take it out again. You can't rely on natural processes. So we have to develop engineering methods to take CO2 out of the atmosphere and bring down the level. Then we can the greenhouse effect will be slowed and can be reversed even. So that's the thing that can save us, but it's the only thing that can save us. So we should be doing this with the utmost urgency. It should be the thing that we devote all our energy to, building systems, designing, building, developing systems for taking CO2 out of the atmosphere, and either doing something useful with it, turning it into rock or something, or burying it under the ground in Iceland.
well,
But getting rid of it anyway.
there we go. I have a task that I can ask some of the Facing Future team that while I still have strength until the cancer totally does away with my ability to use my hands. Oh, it's not the cancer, it's the chemotherapy that I'm going to have to go back on. Gives me such a terrible neuropathy that I have to get someone to type for me. So while I can still type, I can get my team working on trying to research with your guidance the possible routes by which we might remove the most promising routes by which we might remove carbon dioxide from the atmosphere. I know I did a program a couple of years back with David Bierling, British professor, who was into something called, I think, advanced weathering or accelerated weathering.
Yes, that's a method that's been, that's you take olivine rocks and crush them into powder, and they do absorb carbon dioxide. The trouble is you have to spread millions of tons of these things over all the surfaces on Earth.
Well, but it's a fertilizer too. So if you use it as such, and I don't think you have to go to powder, but the more surface area you give, the more carbon dioxide it absorbs. But then it becomes a soil amendment. So it could, with some government encouragement, it could become an industry. But of course, our government is too focused on short-term growth, I believe. So
well, the trouble is you then have to crush some more rock, because it's like a battery running out. So
yeah, no, it's not a fix, but you've got to stop producing the carbon dioxide as well.
I try to keep optimistic because there is one way out, and which is carbon dioxide removal. I've given up on the concept of emission. You need to do emissions reduction, because if you can reduce emissions, then the amount of CO2 you have to take out each year is less. So it's less of a gigantic effort to get rid of the CO2 if you're not putting so much in the first place.
Yeah.
but it's still a gigantic effort, especially if you want the CO2 level to come down so that the climate cools.
Well, as I said, we should do another conversation at your availability while I'm still able to on the carbon dioxide removal, which is one of the few hopes we have for righting the ship before it capsizes. So, anyhow, I want to also mention, though, that in our discussions before, you've mentioned another promising technology or approach. I hate calling it technology because right away the anti-geoengineering faction will get on me if I say there's actually a technology to deal with one of the problems. The aerosol, salt aerosols over the Arctic to protect certain sensitive areas. Just say about that.
If we want to really focus on the Arctic, as like the foundation founded by David King is focusing, saying we must take CO2 out of the atmosphere, but we have to have a separate effort to restore Arctic sea ice. And that's really based on this fear that if you allow the Arctic sea ice to collapse completely, you will have a methane eruption. But the problem is there isn't a good method around, and the two methods that seem to be promising, this is for getting rid of methane, in fact, one of them is blowing a kind of iron chloride aerosol over the surface of the sea, and it combines with methane. That's really untested. It could be the answer, or it could maybe isn't. But the one that is tested and would work, not for methane but for carbon dioxide, is marine cloud brightening, and that doesn't do anything about the CO2. Actually, doesn't do anything about the CO2 level in the atmosphere, but it does increase the albedo of the planet, and that enables it to reflect more energy. And this is just rising, having a load of tube masts injecting very finely divided water particles, nanometer size particles, into clouds. And if they're a certain size, they make the cloud brighter. And the cloud's brighter, it reflects more energy. And marine clouds, which are the stratus clouds, the miserable looking grey clouds that you see above you a lot of the time at sea and also in Britain, those clouds are the things that would become brighter with injection of seawater.
Yeah, from our perspective, they're gray clouds, but from the perspective of if you're above them, they're white and reflecting.
Yeah, and the advantage is that they're low enough that the tall masts that you want to put on, these are going to be put on drone ships. This was all developed in great detail by a scientist called Stephen Salter at the University of Edinburgh, and it's all ready to go. All it lacks is funding, which of course means it might continue to lack that because it depends on the British government. But it's.
Oh, you got to figure out how Boris Johnson can make some money out of it. That's
yeah. He can't afford to take any money out of his corruption budget to simply.
It's interesting that the scientist who's developed it is Stephen Salter, and it's about spraying salt water into the air. I often note with some not irony but some prescience that my parents named me Stuart, and the derivation is Old English for the one who takes care of the land, and I've devoted my life to that.
Yes, well, that's appropriate.